Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on September 26, 2025, about 2 weeks ago. This paper introduces a self-alignment reinforcement learning pipeline that boosts meta-awareness and delivers a 19.3% gain on AIME25 while reaching baseline GARPO performance 1.28 times faster. The paper is titled, Meta-Awareness Enhances Reasoning Models, Self-Alignment Reinforcement Learning. And as we'll see later, the implications for model training are quite significant. It also averages a 6.2% boost across 6 math datasets and improves out-of-domain results, with 3.87% on GPQA Diamond and 2.08% across 13 benchmarks, all without external supervision. Also, the author shared an official MASA RL repo. You'll find the core code and assets, along with a detailed README describing the MASA training pipeline, meta-awareness signals, and how the method aligns rollouts with meta-predictions. It outlines current capabilities and planned integrations and evaluations so you can explore or extend the implementation. So, Figure 1 shows that aligning a model's self-predictions with what actually happens during reasoning boosts both accuracy and efficiency. The left panels compare difficulty and length predictions against true rollouts, where the top scatter drifts off the diagonal while the bottom aligns tightly. On the right, accuracy barely rises with extra train steps, whereas higher meta-aware scores correlate strongly with bigger gains. This matters because meta-awareness means the model can estimate task difficulty and solution length, which guides filtering and early cutoff. Alright, Figure 2 presents how MASA trains meta-awareness by running 2 paths in parallel and then using agreement to guide learning. The left panel shows a meta path that predicts length, difficulty, and notions, and a solution path that produces actual outcomes, which together yield a self-alignment reward. The right panel illustrates meta-based controls. Predictive gating means skipping trivial or impossible prompts. Notion hinting supplies cues, and early cutoff stops long rollouts when unlikely to help. So Table 1 summarizes in domain math results, showing consistent gains when meta-awareness guides training. The top block for the 14 billion model reports a modest average improvement of about 2.5%, which still matters because the baseline is already strong. The bottom block for the 8 billion model shows a larger average lift of about 6.2%. A standout case is AIME25, where accuracy jumps by roughly 19%. So Table 2 reports out-of-domain results, indicating that meta-awareness improves generalization across logic, science, and coding. Pass at 1 means the score from a single sampled answer. In logical reasoning, the average reaches about 71%. Scientific reasoning climbs to roughly 60%. Coding averages near 64%, and a highlight is GPQA Diamond landing around 54%, which shows the gains extend beyond math. Alright, 2 takeaways stand out. Aligning a model's self-predictions with its actual reasoning boosts both accuracy and efficiency, and meta-awareness, especially notion prediction, drives meaningful generalization beyond math. The broader implication is clear. Self-generated signals can guide training, reducing cost with predictive gating and early cutoff. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.